Welcome to the Predictive Analytics, Regression and Classification course. I'm Shorish. I'm an Associate Professor at Chennai Mathematical Institute. In this course, I'm this course in CMI for about 8 years now, and most of my materials are based on mainly two books by James Witten-Hesti and Tibshirani's Introduction to Statistical Learning and Hesti Tibshirani-Friedman's Elements of Statistical Learning. Now, recently, Andrew Gilman and his colleagues Jennifer Hill and Aki Thori has written a new book called Regression and Other Stories. I like this new book as well. So most of my material in this course are going to come from these three books. I'll motivate you for a predictive analytics problem with this example. Imagine yourself, you are working in an automotive car manufacturing company and you are supposed to design a new car. Now you have due diligently designed this new car, and now in this car you have specified every bit of things in this new prototype car, but you don't know what would be the miles per gallon of the car, because maybe horsepower or displacement and other engineering feature you can define using your engineering concepts, but miles per gallon is not really an engineering concept in that sense. It's just a measure of fuel efficiency. So effectively, you want to measure the fuel efficiency. All you have to do, you have to really make a car, and then you have to run the car for a while, and then you can make a measure of fuel efficiency for that car. But that is very costly, expensive exercise, and many car manufacturing companies might not try to do that. So what you can do instead, we can develop a mathematical predictive model which will tell you, based on all the engineering features and based on historical data, that what would be the miles per gallon for the prototype car. Here is an example data for a new prototype car. Like this is a one model, particular model, Mazda RX-4, which is a 6-cylinder car. Displacement is 160, horsepower is 110. There is another car, maybe Datsun 710, which is a 4-cylinder car with displacement of at 108 and horsepower is 93, and the miles per gallon is 22. Similarly, Hornet 4Drive is another new car, which is a miles per gallon 21.4, 6-cylinder car, displacement of 258 and horsepower of 110. Now you have a prototype car, new prototype car, which you have thought of, okay, let me design this car with 4-cylinder car with a displacement of 120 and horsepower of 100. Now, what would be the miles per gallon of this new prototype car? Can you predict this value? Can you predict the miles per gallon? This is precisely the kind of problem we will be talking about in this entire course. This particular dataset is typically known as MT-CARS dataset. It's available in R. Also, I will make this available along the course so that you can do your exercise in Python. Here is another second example on predictive analytics. Imagine yourself a manager of a bank. Now somebody applies for a bank loan. Now, given the credit history, or a housing loan or a car loan, now given the credit history, and other features like maybe the educational qualification, whether the person works or not, etc., etc. Given these kind of features of the loan applicant, bank manager wants to predict if the loan application would become a good or a bad loan. So our objective is to predict the label of the loan, either the potential customer is going to be a good customer or bad customer. If it is a good customer, they will take the loan, they will pay the interest and or EMI absolutely on time, and they will return the entire capital on time. But if it is not good customer, they may default on their loan, and in that case bank may have to incur a big loss. So this is a very important problem for bank manager. So she or he wants to predict whether a loan applicant is a good loan applicant or not. Now, how to identify if a problem, a business problem, a statistical, scientific problem, any problem is a predictive analytics problem? Ask question to your client, your collaborator, do you want to predict something? If the answer is yes, then ask which variable you want to predict. Check if that variable is available in the database. If yes, then you can consider it as a predictive analytics problem. So when we say predictive analytics, you can ask me a question, do you mean supervised learning in the machine learning literature? Supervised learning algorithms are trained as using labeled data. So for example, a piece of equipment could have a data points labeled as failed or it runs. And based on the features of the equipment, you want to predict whether the machine is going to fail or going to run for next 1 month. So here objective is to learn the F. That is our objective. So yes, predictive analytics is exactly the supervised learning. In typically statistics and in business, we call it predictive analytics, and in machine learning literature, we call it supervised learning. In supervised learning, typically there are two types of problems. The first problem is called regression, and the second problem is called classification. In the regression, target variable y is continuous variable. For example, you want to predict somebody's income or somebody's blood pressure, or you just want to predict the distance from one place to another place. Classification, on the other hand, is target variable when it is categorical or a level variable. Suppose based on the feature of a animal, you want to predict the species type or the subspecies type of the animal or the plant. Based on you want to predict the color of the car that will be most bought in the market, or you want to predict class. So this is whenever it is a categorical variable, this is a classification problem. Your target variable is categorical variable, it is a classification problem. But if your target variable is a continuous variable, then it's a regression problem. Typically what we do, our data set will have a bunch of features. Like here in this case, I'm assuming we have P features. Each column represents a particular feature, and each row a sample represents a particular sample or instances. So in machine learning literature, each row will be called instances, and typically in statistics literature, it will be called samples. Now, in a typical predictive analytics or the supervised learning setup, each features. These are called typically X will be the features and Y will be your response or target variable. And we are here considering n many samples or n many instances. And this part of the data typically called the train data. And then there will be a test data where you may have m many samples or instances and where you don't know the value of the responses. So based on the train data, we will fit the model, we will train the model, and then based on the test data, we will try to predict what would be the value of y for these new test data point or test points. So in this case, what we found, it is here it is a quantitative response, so it will be a regression kind of problem. And in this case, when it will be qualitative response, it will be classification problem, but we will solve it exactly in the same way. We will have bunch of features and many samples, and each sample will have some categorical response, and we will build a model. Based on the model, for the response for the test cases, we will predict what would be the categorical response. Now I am going to set up a ask yourself question session. Pause the video, read these questions carefully, and think for a while and come up with the answer if it is a predictive analytics problem or not. So the first question is, can you forecast what would be the demand for the product next quarter? Second question, a pharma company wants to determine if particular disease phenotype is associated with hypertension and type 2 diabetes. Third question, from mock test, can you predict what would be expected CAT or CAT score for a student? And the fourth question, bank executives want to identify if a woman customer with salary account would be interested in car loan. So pause your video for a while, think about it, and write down your answer, and then start the video. I'm going to give you the answer in the next slide. Can you forecast what would be the demand for product next quarter? Now you see the forecast, I marked it as a red color. So it is this is a keyword that will give you that is giving you the answer that yes, it is going to be a predictive analytics problem, because we want to predict what? We want to predict demand in the next quarter. Now the second question is a little bit tricky. A pharma company wants to determine if a particular disease phenotype is associated with hypertension and type 2 diabetes. So it is not predictive analytics problem. However, maybe we will be interested using regression type model or a classification type model to figure out if indeed hypertension and type 2 diabetes is associated with disease phenotype. Now, this particular problem can be approached by two methods. Either you just see what are the association and correlation between these variables, disease phenotype, hypertension, and type 2 diabetes, or you can set up a regression model also, and from the regression model, try to figure out if there is any association between these variables. So we are not interested in this problem. We are not interested in predicting anything, but still the same predictive model, we will see future that same predictive models can be used to understanding association between the variables. From the mock third question, from the mock test score, can you predict what would be the expected get score of a student? Now here clearly you want to predict something, so it is indeed predictive analytics problem. And the fourth and final question, bank executives want to identify if woman customer with bank salary account would be interested in car loan. Here also you will see that association is something that is what we are interested in. Similarly, in banking and in corporate, it will be considered as a market segmentation problem. You can use simple market segmentation technique or the database segmentation technique to identify if they are interested or not. You can use regression or classification type model also to use this. So directly, no, it is not predictive analytics kind of problems, but what you are interested in a little bit more on the association, finding the association between the women customer, if they have a salary account and would be interested in the car loan or not. Now, natural question that comes to our mind now, so what is the difference between prediction and association? So in business, what we call prediction and forecasting, or business and statistics, in machine learning and statistics we call it supervised learning. And in business, typically oftentimes we are interested in association between different market segmentation. This comes under what we call unsupervised learning or machine learning, or in machine learning and statistics jargon. Now, you must ask a question to yourself, why we should learn regression. Some of the most important use of regressions are, I would say, the most four important uses of regressions: prediction or forecast a new test point. Second is exploring the association, or typically we call it inference, statistical inference in statistics, summarizing how well a predictor variable predicts the outcome. Exploration adjusts for known differences between the samples. A familiar example is predicting poll results. And finally, the causal inference, perhaps the most important use of regression, is for estimating treatment effects from randomized study. If you have a randomized clinical control study, from the randomized clinical control study, if you can make causal inference, and in that case a regression classification model play a huge role. Now one more ask yourself moment, so is it a predictive analytics problem? A bank runs direct marketing campaign phone call to its existing customer database. If an AI system can predict which customer is more likely to subscribe the credit card, then they save a lot of effort and time by calling the customer who are more likely to subscribe. Now, please pause your video and then think about it for a couple of minutes and identify if it is indeed a predictive analytics problem. Yes, indeed, it is a predictive analytics problem. It is actually classification problem. And with that, we are going to stop this video and we will move on to the part B of this lecture. So thank you, and please carry on to the part B of the lecture. You may take a small break here and come back and let's continue on part B.